Okay, so this is going to be kind of an introduction to completing the square. First, we're going to review quickly factoring. Not just any kind of factoring though. These are all going to be perfect square trinomials. So you're not always going to be able to factor this way, but this will give us a starting point. Okay, so we're going to factor x squared plus 8x plus 16, and just to help you remember, factoring means change it to multiplication. So we look for greatest common factor first. Here, our greatest common factor is a 1, so we don't have to worry about that. It is a perfect square. It is a quadratic trinomial. So we're going to turn it into two binomials that we're multiplying together. X times x times x will give me my x squared. We're looking for two numbers to multiply to give us a positive 16. And then we'll end up having to also get our positive 8x. We'll worry about that in a second. So positive 16, we can have 1 and 16, 2 and 8, 4 and 4. We're going to use 4 and 4. 4 times 4 does give me the 16. Now, to get the middle term, we've got 4x and 4x. Those added gives me my 8x. So when we multiply that back out, we do get our original trinomial. Because these are exactly the same, you can combine them and write it as x plus 4 quantity squared. And because this factors into a perfect square, it's a trinomial. That's why it's called a perfect square trinomial. So we're going to do one more like that and then try to find the pattern. So once again, greatest common factor is 1. X times x will give me x squared. To get the 36, we can have 1 and 36, etc., etc., etc. We're going to use 6 and 6. If I multiply 6 times x, I get 6x, and 6x times 6, I get, again, 6x. But I do want to add to get a negative 12. So these will be negatives. Negative 6 times negative 6 is still positive 36. Negative 6x, negative 6x adds to negative 12x, so we're all good there. They are exactly the same, so we can combine them and write x minus 6 quantity squared. Okay, I know that was pretty fast, but it should have been review, I hope. Now we look for a pattern. So, shortcut. Square root of the x squared gives us x. Square root of the 16 gives us the 4. In order to get the 8, these are exactly the same, so we double it. If this is not a 1, you do have to multiply the coefficients here. 1 times 4 gives you 4, doubled gives me the 8. So in order to get the 8, we can take the 4 times the x multiplied by 2, gives me the 8. Same thing here, square root of x squared gives me x, square root of 36 gives me 6. Negative 6 times x doubled gives me negative 12x. So when we're doing problems like this, excuse me, we want to create perfect square trinomials. So what we can do is take the reverse of that. So we take this 10. We want to know what this number has to be to give me my perfect square trinomial. So we're going to take the 10, divide it by 2, so that's the reverse of doubling it, and square it, because that's the reverse of taking the square root. That gives me 10 divided by 2 is 5. squared gives me 25. So this should be a 25. And if we double check, square root of x squared is x, square root of 25 is 5. Okay, take this sign. 5 times x is 5x, doubled gives me my 10x. So it worked. Try another. Negative 20 divided by 2 squared. Negative 20 divided by 2 is negative 10. Squared is 100. So this should be 100 to make it a perfect square trinomial. Let's double check. Square root of x squared is x. Square root of 100 is 10. First sign, squared. Negative 10 times x is negative 10x. Doubled is negative 20x. One more, a little trickier. What makes it trickier? Well, this is odd. Same idea though. Divided by 2 squared. 5 is not divisible by 2, so we're just going to leave it as a fraction. It's okay. 5 squared is 25. 2 squared is 4. That should be what goes here. If we factor it, x square root of x is x squared. Square root of 25 fourths is 5 halves. Square root of 25 is 5. Square root of 4 is 2. First sign. Okay. X squared, 5 divided by 2 squared is 25 fourths. 5 halves x doubled is 5x. Okay.